Hi, good day, doctor. My name is James Guan. I'm from SEMM2713 Section 6, Manufacturing Process. Today, I'm going to present a study of polymer with the title of Application of PDMS in Microfluidic Field. In this presentation, there are two parts of it. First, I will introduce to you what is polymer and elastomer, and with this understanding, we can move on to study what is PDMS and what exactly PDMS is used for. So first of all, I would like to introduce to you what polymer is. So a polymer is actually a combination of very large amount of molecule, which each of them are a simpler chemical units that are called monomers. And polymer actually consists of different types. The first one will be linear, followed by branch, cross-link, and eventually networking. So elastomer is actually a specific type of polymer, as I described previously. It has cross-linked molecular structure that make it exhibit rubber-like elasticity and high deformation capability. Elastomer actually having high elasticity and flexibility. It is having good resilience and damping property. And although it have low tensile strength, but it's a good electrical insulator and it didn't contact electricity. After having the fundamental knowledge on what polymer and elastomer is, we can move on to study what PDMS is. So PDMS stands for polydimethyl siloxide. It's actually a silicone elastomer. Since it is an elastomer, it definitely has a really good flexibility. A special thing about PDMS is that it has optical transparency. Also, it's simple to be fabricated, means that we can make it in a very large scale and amount. It's also having good stability in chemicals, so it's inert, you can say, and it has biocompatibility, which won't harm our human body. It also have a good biodegradable, so it also won't cause any harm to the environment. This PDMS having some good mechanical property that make it suitable for a wide range of application. And here are some of the example of application. First one will be chemical analysis, missing biosensing, particle separation, and also it can be used to make microfluidic droplet. All these processes are actually possible on just a piece of chip. Here are some of the example of application of PDMS. So it can be applied in chemical and materials fields, mechanical and fabrication field, as well as biomedical field. Why do I say so? Because PDMS is a material that is really suitable to be made as the basement of experiment apparatus. It's actually a jelly-like material, so we can modify it into the shape that we desire. So for example, this is one of the most important application of PDMS, which is to be the basement of a chip. So as you can see here, when we having certain shape on the chips, we actually can make it to be a laboratory in a micro level. So means that we can mix all the experiment on a piece of chip only, and it's really save a lot of space and also the budget, the cost. So let us see how PDMS is being applied as a chip for microfluidic device. So as you can see here, the one in blue will be water and the one is in white will be the oil. So as you can see, as the water pass through the oil, it will become a micro droplet, which is a very small droplet, and it will be passed to the hole. Then all this micro droplet of water will be collected to a bottle where a pipe. So as you can see here, we can collect the micro droplet in a small bottle using this process, and actually we can mixing two and more substance together using this micro droplet. And what is the advantage of doing so is that we actually can customize what is the concentration of each of the substance. Then we can come up with a set of different sample with different concentration, so we can compare it with each other. And yeah, here will be the end of the presentation. Here will be all the reference that I used to make this presentation. So that's all from me. Thank you for listening, Doctor. Bye.